Hello everyone, my name is Dang and this is part 2 of day 13. This is my series of speaking English every day. Today I choose the physics topic to read to enhance my vocabulary, also practicing my speaking fluent. And the title of the speaking today is Newton Explains Motion. Although many scientists studied motion, it was the great Sir Isaac Newton who formulated theories of motion, verifying and extending the early work of Galileo and Copernicus. Newton studied horizontal and vertical motion. First, Newton studied the quality of inertia, or the tendency of a body to resist change in its state of motion or direction. A tennis ball, for example, has a little inertia. It is easy to get it to move, stop, or change direction. A stock, on the other hand, has a great deal of inertia. Newton concluded that a body at rest will remain at rest and the body in motion will remain in motion unless some outside force acts on it. This principle is called the law of inertia, or Newton's first law of motion. But Newton's curiosities were not satisfied. He wondered what causes a change in motion. Why does a body at rest begin to move and a body in motion change its direction? He determined that if a body is at rest, no force is acting on it. However, when a force acts on a body, the force will speed up or slow down or change the direction of that body. Moreover, Newton discovered that there is a relationship between force and acceleration. If you push a swing gently, it will move so slowly, and if you push it harder, it will go faster. Newton noted that if you discount the friction involved, the amount of force is directly related to the amount of acceleration. The acceleration is also related to the mass of an object. Mass, which is the quantity of matter in a body, also determines the amount of inertia an object has. A stock has a great deal of mass, a particle has much less. If you use an equal amount of force to push a particle and a torque, the particle will move faster than the torque. The larger mass, the less acceleration. In fact, the acceleration of a body is inversely proportional to its mass. Newton's second law of motion states that the acceleration of a body is directly related to the force acting on it and inversely proportional to its mass. The direction of the acceleration is in the direction of the applied force. Finally, Newton explored the question of source of force. He observed that the force acting on a body comes from another body, but this idea itself was not consistent with his view of a balanced and symmetrical universe. He therefore concluded that whenever there is a force pushing in one direction, there is another force pushing back. This concept may be difficult to imagine, but try pulling on a rubber band and you will feel it pull back on you. Also notice what happens to your fingers when you press it against a table. Objects can exert a force because all materials are elastic to some extent, although the elasticity of walls and tables may be slight. When you push off against the wall or swimming pool, for example, you start to move away from the wall. The wall is exerting a force on you that causes you to move in the opposite direction. And if you think the floor does not push back against your feet, why do your shoes wear out? And why do your feet hurt you after you have been them on for a long time? Why do automobiles tires wear out? Thus, Newton stated his third law. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. The movement of a rocket is also based on this law. The rocket expels gases, which then exert an equal and opposite force, propelling the rocket forward. In space, a vehicle can alter speed or direction by expelling rockets in the opposite direction. Newton's laws are applicable everywhere in the universe and synthesize both vertical and horizontal motion. The concept that the universe functions according to logical, orderly, natural laws influence not only the scientific world but also the social, political, philosophical thinking of the Western world for 200 years. And this is the end of today. Thank you for listening.